Good morning, students. In today's class, we will learn, see, chemical properties of haloalkanes. Chemical properties of haloalkanes. Good morning. Record So today's class we will learn about chemical properties of haloalkanes. In this class, see, first chemical property which we have learned of haloalkanes was nucleophilic substitution reactions. Nucleophilic substitution reactions. Nucleophilic substitution reactions. जिसको हम लोग प्यार से SN कहते हैं. And you know SN is of how many types? First one SN1, next one SN2, last one we did SNI. है ना? 3 types of SN we have learned: SN1, SN2 and SNI. है ना? This we have learned in previous classes. Chemical properties में SN1 क्या होता है, SN2 क्या होता है, SNI क्या होता है, where we have to do SN1, SN2 and SN. Next we have learned about elimination reaction. Elimination reactions. See, in elimination reactions we have learned that elimination you have to do. So how many types of mechanism we have? Elimination E1, E2 and even CB. And there is also one more for advance, for the advance one. है ना? वो हम लोग जे advance में we will talk about. So first one is E1, E2, E1, CB. One more is there. So these 4 are the 4 mechanisms of eliminations. है ना? After this, today's class we will learn about reaction of alkyl halides with metals. Reaction of alkyl halides with metals. Today's class we will learn. Let's see. So first reaction which we will learn today is known as Wood's reaction. You all know about Wood's reaction, है ना? अब सभी ने पढ़ा है. So what will happen in Wood's reaction? Let's say I have CH3Cl, simple alkyl halide, and I put in this reaction sodium in dry ether. Sodium in dry ether, है ना? Sodium in dry ether. Sodium is a metal, therefore these reactions are known as reaction with metal, alkyl halide and metal reactions, है ना? So what will happen? यहाँ पर बनेगा CH3CH3 plus देखें 2 times of NaC. See, CH3CH3 plus 2 times of NaCl. So how this will happen if we take 2 moles of CH3Cl? देखिए 2 मोल लिए, मतलब कि you have CH3Cl plus Na plus you have CH3Cl 2 moles, 2 moles of CH3Cl, and I put here in dry ether. So what will happen? NaCl will come out as precipitate. ये NaCl will come out, and this carbon will make a bond, है ना? So this carbon CH3 and this carbon CH3 will make a carbon-carbon new bond, है ना? देखिए यहाँ this NaCl will come out. This NaCl will come out. So write this. This is for symmetrical alkene. symmetrical alkyl halide. When you have symmetrical alkyl halide, you have a single alkyl halide, you will get even number of carbon chain. You will get even number of carbon chain. Matlab, if you have single carbon here also, single one molecule of this, दोनों carbon single है, you will get even number है ना, एक का एक 2 हो गया, 2 will be 4, 3 will be 6. देखें, let's say I have odd number of, or you can say unsymmetrical alkyl halide. If I have unsymmetrical alkyl halides, let's say I have CH3Cl plus C2H5Cl. Two alkyl halides I have, one with even, one with odd. And sodium in triether I am putting. So what will happen? This Na and this Cl, है ना? This Na and this Cl will go. This Na and this Cl will go. देखें, this Na and these two Cl will go. So what will happen? अगर मैं यहाँ पर CH3Cl ले लूँ and 2 times of Na ले लूँ और Cl ले लूँ C2H5 वाला, है ना? Same way. So this NaCl, 2 molecules of NaCl will go. So what is made? CH3 and C2H5 bond is made and 2 times of NaCl will go. See? So if I have unsymmetrical alkyl halides, these two are unsymmetrical, one is C2H5, one is CH3. So I will get odd number of carbon chain. मतलब मेरे को odd number of carbon chain मिले, 2 plus 1 3. So I will get 3 carbon chain here. 3 कार्बन का चेन मिला. समझ रहे कि नहीं? है ना? So possibility in this reaction, one more possibility is this, कि this one will attack with itself, है ना? If you have to, इसके अंदर 1 mole में बहुत सारे molecules हैं. 1 mole, you have taken 1 mole. In that 1 mole you have Avogadro number of molecules. So what possibility? Other possibility is that CH3Cl can itself attack itself, है ना, with sodium, है ना? So it can also make CH3 also. This is also one possibility, है ना? One possibility, other possibility is that C2H5 will itself attack on C2H5Cl, है ना? तो वो वाला और सोडियम के साथ रिएक्ट करके one more possibility is there, you will get C2H5 and C2H5 bond. Understanding or not? So you will get 3 products here, and 3 products. One CH3 C2H5, which is unsymmetrical, and these two are symmetrical. These two are symmetrical elements, है ना? So this is with itself, ये वाला अपने साथ ही, ये वाला अपने साथ ही CH3Cl के साथ, and this one will be going with cross, है ना? CH3Cl and C2H5 के साथ cross unsymmetrical alkyl halide करके, and you will get this as alkenes, है ना? ये हमें आपको alkenes मिलते हैं, है ना? So in any reaction, if you want to increase the carbon number, if you increase the carbon number by double, by triple, है ना? Let's say I have CH3, I need to double it, triple it, है ना? तो this reaction is the best reaction for increasing the carbon number, है ना? So see, we have 3 products. We have 3 products in which we have CH3, in which we have CH3, C2H5, and we have C2H5 and C2H5, है ना? So out of these products, we can separate them. See, है ना? So they have different molecular masses. So little difficult it is. Little difficult it is to separate. See, all these are non-polar compounds, है ना? Their molecular masses are also comparable in some range, है ना? ज़्यादा difference नहीं है. So little difficult it is to separate, है ना? So this is the little, है ना? This is somewhat little bad reaction, you can say, because you are getting many products. And if you want only one product and you are getting many products, that reaction is not good at all. And in that reaction, if you are getting single product, that is reaction is more good. So out of these three, आपको ये वाले याद करने हैं, है ना? This is a type of good reaction. Whenever you have sodium in diether, you should know you are doing good reaction. One more example, if we take, देखें, if I have CH3Cl plus zinc, if I have CH3Cl plus zinc, in place of sodium, I use zinc in dry ether. Same product I will get CH3 plus zinc chloride, ZnCl. Same product I will get. See. And this is known as Franklin's reaction, beta. Franklin's reaction. In place of sodium, if you use zinc, that is known as Franklin. If it is used as sodium in dry ether, it is Woods reaction. याद करना है, लिख लें इसको. Second type of reaction, 3.2, it is reaction with metals. देखें, let's say in this reaction I use one alkyl की जगह I use aryl halide. Aryl halide. An aryl group being phenyl group or any other group. Aryl halide plus I use 2 moles of sodium and I use CH3Cl. देखें, और सिंपल यही वाला आप ले लें. अगर आप सिंपल ये ले लें, ये सिंपल आप ये वाला ले लें, 2 moles of this and 2 moles of this in dry sodium in dry ether. If these 2 moles are used, what will happen? These Cl and this sodium will give you NaCl, 2 moles, and 2 moles of this alkyl halide will combine to one another, है ना? Carbon carbon bond बनाएंगे and you will get a compound which is known as biphenyl, है ना? आपको क्या मिलेगा? You will get biphenyl, है ना? See in this कैसे हुआ ये? You have one Cl, you have 2 moles of Na, you have another Cl. So this Na and Cl, this Na and Cl will combine and you will get this carbon and this carbon will combine with one another. You will get what? Biphenyls. You will get what? Biphenyls plus 2 moles of NaCl. Understanding or not? सो अगर 2 मोल हमने इसके यूज किए, 2 मोल सोडियम के यूज किए, यू विल गेट बायफिनाइल। बायफिनाइल मतलब 2 फिनाइल रिंग्स ज्वाइन टूगेदर। देख लें। सो दिस रिएक्शन इज नोन एज फिटिक रिएक्शन। FITTING, फिटिक। FITT, this reaction is known as FITTIG, फिटिक रिएक्शन। इसको हम लोग फिटिक रिएक्शन कहते हैं। whenever you have in place of alkyl halide you have an aryl halide, है ना। similar way of woods, है ना, similar way of woods, in woods you have aliphatic, है ना, and in phytic you have aromatic alkyl halide। simple। लास्ट वन देखें, वी हैव वुड्स फिटिक। वुड्स फिटिक, वुड्स फिटिक रिएक्शन। देखें व्हाट विल हैपन इन दिस। Let's say in woods fitic, I have one aromatic alkyl halide and I have one aliphatic alkyl. So one, if you have one aliphatic, one you have aromatic, so ये वाला तो फिटिक देगा, ये वाला वुड्स देता है ना। So if you have these two in sodium in dry ether, sodium in dry ether is used, these two are given. So you will make NaCl, you have to remove, NaCl you have to remove, NaCl you have to remove, and you will make the bond between carbon and carbon, which one? Between this phenyl, between this phenyl and CH3. See? And now here in place of CH3 you can have R group also, any group you can have बेटा, कितना भी बड़ा हो सकता। लिख लें। Oof. लिखा। So this is known as Wood's fitic, है ना, by the name only. This is CH3Cl is Woods, and with aryl halide you will get fitic, है ना, दोनों को कंबाइन करके Wood's fitic। See beta, in Woods fitic reaction what will happen? It can also give two Woods reaction, है ना, CH3Cl अपने साथ भी कर सकता है, so it can also give this product also, CH3CH3, है ना, ये अपने साथ भी कर सकते हैं CH3CH3। This also can go for fitic reaction, pure fitic reaction with sodium, and because many mole, 1 mole you have taken, 1 mole में Avogadro number of molecules are there, है ना, so many molecules are there for its reaction, so it can go for making biphenyls also. It can go for making biphenyls. So in this reaction of Wood's fitic, you will get three products, है ना, you will get three products, and these three products are easily separated, and we can easily separate them. So these can be separable because they have different or greater difference. Their difference between molecular mass is high. Difference between their molecular mass is greater, है ना, क्योंकि डिफरेंस इनकी मॉलिक्यूलर मास का ज्यादा है, यू कैन इजीली बी सेपरेट by many techniques, है ना। you have learned in purification of organic compounds, you have many techniques, है ना, distillation, chromatography, many techniques you have. Done. Write this beta, 2 minutes I am giving to you. So reaction with metals, you have Woods reaction, Franklin reaction, Fittig reaction, and Woods Fittig reaction. Yes, beta, the two. One question asked, sir, in Woods reaction, do other two products form? Yes, beta, all the three products are formed. NaCl, sir, toluene, NaCl will not be formed. Beta, NaCl will found in toluene. In where toluene? यहाँ पर भी सभी में बनेगा NaCl, beta. If you have NaCl is, we can get NaCl in all, beta. NaCl we don't even care, beta. We care for our product. With a major minor we don't know. Major minor we don't know. All three will be formed in different amounts. है ना? Changing the concentration of reactant and changing the conditions, we can make our major product. Which one you want? Intramolecular goods. हाँ बेटा, this is the intermolecular goods, बेटा. This is the intermolecular goods reaction. This is the intra and this is inter, है ना? If you have inter, दो कंपाउंड के बीच में एक ही साथ में हुआ तो CH3 you will get. Of same compound you will get biphenyl. And if you have this aromatic and aliphatic ring, you will get Woods Fittig. And this is Woods, this is Fittig. ये वाला तो Fittig के साथ, ये वाला Woods के साथ, और ये वाला Woods Fittig के साथ. Simple it is. डिफरेंस किसी में कुछ नहीं है भाई, एवरीवन इज सेम. नो डिफरेंस बिटवीन वुड्स फिटिक, बेटा. कोई डिफरेंस नहीं, कोई डिफरेंस नहीं है. एवरीवन सेम है. दैट इज, सी वुड्स इज फॉर एलिफेटिक एंड फिटिक इज फॉर एरोमेटिक. Simple. If you use zinc in place of sodium, that is Franklin reaction. And if you use zinc in place of sodium, that is Franklin reaction. Just you have to see you are doing cross या उसी कंपाउंड के साथ कर रहे हैं, उसी के साथ कर रहे हैं, you will get that two carbon carbon bond. You know, if you are doing with two compounds, different compounds, then you will get a different product. And you will get here, this is known as toluene. You will get toluene from here. And this is known as biphenyl. This CH3CH को ethane. Ethane you will get, toluene you will get, ethane and biphenyl. Three products you will get. And they can be easily separated because they have different molecular masses. Difference between molecular masses is very high. Next thing we will write, beta. Fourth, this is the fourth product. देखें last, this formation of Grignard reagent. Very important topic this is for JEE mains and JEE advanced perspective. Totally different chapter is given on Grignard reagent in MS Chauhan. Yeah, see, Grignard reagent is known as RMGX. And R is, can be aliphatic or can be aromatic. R can be aliphatic or can be aromatic. Okay. So in the, when you have RMGX, R carbon and metal bond. Whenever you have carbon and metal bonds, metal will act as electropositive and carbon will act as electronegative. देखना बेटा, because all metals are where left side of the periodic table, so these all metals are having electronegativity very low in comparison to carbon. कार्बन हैव इलेक्ट्रोनेगेटिविटी 2.5, है ना, याद रखें, कार्बन की इलेक्ट्रोनेगेटिविटी तो 2.5 होती है. So if carbon has electronegativity 2.5, if carbon has electronegativity 2.5, carbon is more electronegative than metals. So in RMgx, you will get R as negative, Mg as positive, X as negative, Mg as one more positive. So Mg will be 2 positive, R will be negative, X will be negative oxidation state and vector. देखें, so these compounds in which you have metal and carbon bond, carbon metal bond, carbon and metal bond, these compounds are known as organometallic compounds. These compounds are known as organometallic compounds. जिसके अंदर कार्बन और मेटल का बॉन्ड होता है, उन कंपाउंड को हम कहते हैं ऑर्गेनोमेटालिक कंपाउंड्स. सी, फर्स्ट वन, सी हाउ टू प्रिपेयर, preparation of Grignard, preparation of Grignard reagent, GR I am writing in short. देखें, let's say I have aryl or alkyl halides. Let's say I have bromine or chlorine or fluorine, anything you can take. If I put them in magnesium in dry ether, if I put them in magnesium in dry ether, what I will get, this magnesium will go and will be placed in between R and Br, है ना. So you will get RMgBr, RMgBr, है ना. And this only is known as Grignard reagent. For Grignard reagent, you have to treat alkyl halides with magnesium in dry ether. You will get RMgBr. देखिए, so this was preparation. Let's say I prepare Grignard reagent of CH3Cl. क्या करना है? You put Mg in dry ether. You put Mg in dry ether. बेटा इसी को Mg को ही बोलते हैं, Ca को नहीं, स्ट्रोंशियम बेरियम को नहीं, है ना. है ना. Grignard, you will study the story of Grignard, how it was discovered. Grignard, what a name of the scientist. We can't use sodium, strontium, barium, beryllium. We can't use. Mg को ही लिए. So let's say I have CH3Cl, I put Mg in dry ether, you will get CH3MgCl. देखें, then write this. Let's say I have here, let's say I have benzene, chlorobenzene. How to make the Grignard of chlorobenzene? Put magnesium in dry ether. So magnesium will come between carbon and chlorine. You will get benzene, then you will get MgCl. You will get MgCl in between carbon and chlorine. Then you should know that carbon is negative, magnesium is positive, है ना. देख, Now we will see reactions. This was preparation. Now we will see reactions of Grignard reagent. Reactions of Grignard reagent. Let's see reactions of Grignard. Reactions of Grignard reagent देखें. Let's say I have CH3 MgCl and I put in this reaction alkyl halide. So this CH3 negative will be there. It will go and give a backside attack SN2. It can go and give a backside attack and remove Cl minus. है ना? So यहाँ पर ये CH3 it can make. Same as Wood's reaction. It can make CH3 and CH3. देखें. And you will get one more MgCl2. And MgCl is removed, Cl minus is removed, it will come with MgCl and it will make a salt MgCl magnesium dichloride. So you can make CH3 by Grignard also. So two methods are there if you want your alkyl halide to increase the carbon number. First method is you can do Wood's reaction. Second method is you can do Grignard reaction. Let's say I have, देखें, let's say I have CH3Cl 1 mole, you have magnesium, you have 1 mole CH3Cl, you have 2 moles of CH3Cl, magnesium in dry ether. So what will happen? 1 mole of CH3Cl and MgCl will make a Grignard, CH3 MgCl. This Grignard reagent is made. Now this Grignard reagent will attack on the next mole of CH3Cl to give you CH3CH plus MgCl. मतलब in the reaction, if I use 2 moles of CH3Cl plus magnesium in dry ether, if I use 2 moles of CH3Cl magnesium in dry ether, I will get CH3CH3 similar to Wood's reaction, and MgCl2. See, देखें, समझ आ रहा है आपको? In Wood's reaction we use sodium, but in Grignard we have used magnesium. Mechanisms are totally different, but product is same. There also we got CH3 ethane in Woods. Here also we can get CH3. देख लें. तो हमेशा याद रखें, whenever you have 2 moles of alkyl halide with magnesium in dry ether, you will get CC coupling. CC bond will be made. So this C and chlorine bond is broken and CC bond is made. है ना? चले, one more thing we will see. This is first reaction of Grignard. Second one we will write. Let's say I have a Grignard RMgX Grignard reagent. And if this Grignard reagent is present in solvent, any solvent, you know, in solvent which is having active hydrogen. Active matlab you can take that hydrogen easily. Solvent having active hydrogen. Let's say I have Grignard. I have H2O. I have CH3OH. I have C2H5OH. These are all solvents, polar protic solvents, है ना? अगर मेरे पास ये है और अगर मेरे पास लेट्स से मेरे पास एसिटिक एसिड है ना? एसिटिक एसिड है. लेट्स से आई हैव अमोनिया, and if I have these solvents, so what will happen? This Grignard will act as what? This Grignard will act as a base. It will take the H positive from the solvents, है ना? So अगर इनके साथ ये आ गया तो ये R negative will take the H positive of the solvents. R negative will take the H positive of the solvents and will make R and H. And it will make alkanes. And rest part will be gone. जैसे MgX will be gone with OH because H positive gone, OH negative remaining. OH negative will go with MgX. Next you have MgX with H positive gone, CH3O. Then you have MgX with H positive gone, C2H5O. Then you have MgX here, CH3COO. Last you have NH, MgX and NH2. And these are side products, But if you have, see, whenever you use Grignard reagent, we make sure that in the solvent we don't have active hydrogen solvent. क्योंकि अगर एक्टिव हाइड्रोजन आ गया वो तो वहां पर एसिड बेस रिएक्शन करवाएगा, है ना? एनी टाइम यू सी एसिड बेस रिएक्शन that is more prone than substitution, then elimination, then addition. And we have discussed acid base first, then addition, then substitution, and last is elimination in this context. है ना? So let's say I take an example, beautiful example I take. This is also asked in sometimes. Let's say I have, here chlorobenzene. I have. I put Mg in dry ether. So you will get here what? If I put in Mg dry ether, you will get Grignard of this. तो यहाँ बनेगा MgCl. Then, so if in this MgCl I put water, in this Grignard reagent I put water. So what will happen if I put water? This all MgCl will gone. Hydrogen will come. So you will get benzene. Understanding or not? Write yes or no in the chat box. Chat box में yes or no लिख दें. So if you have a chlorobenzene, अगर chlorine थी, if you want to remove chlorine from here, you can make Grignard, है ना? You can make Grignard and you put water into it. You put water into it, you will get benzene, है ना? हाँ repeat कर रहे, don't worry बेटा, repeating it again now. So if you have here, first you will form Grignard in Mg in dry ether, then you can make benzene. See, benzene to chlorobenzene we have learned is Which reaction? Chlorination of benzene. Chlorination of benzene. We have learned in electrophilic aromatic substitution EAS. You have to put chlorine plus anhydrous AlCl3 from benzene to chlorobenzene. But chlorobenzene से back benzene बनाना है तो you can make grignard and you put water. फूक दो. It's called क्या? आग लगाओ, फूको. Understanding or not? Write this better. Write just the upper one. नीचे वाला तो is part of chlorination. चले बेटा. With this are part of haloalkanes. Reactions of haloalkanes is over. Again, I will repeat from the starting only. We have done nucleophilic substitution reactions. Then we have done elimination reactions. Then today we have done reaction with metals. First reaction was Woods reaction. You have learned that if you have symmetrical, you will get even number. If you have unsymmetrical, you will get odd number. For Woods reaction, you should have sodium in dry ether. Similar way, if you are using zinc in the reaction, that is Franklin reaction. If you are doing with aryl halides, if you are doing the reaction with aryl halides, if you are doing the reaction with aryl halides with sodium in dry ether, that is known as phytic reaction. If you are doing it with aryl and alkyl both, that is known as Woods phytic reaction. aryl और alkyl दोनों है, aryl halide और alkyl halide दोनों है, तो हमारे पास Wood phytic होगी. Lastly, we have reaction of Grignard reagent. How Grignard reagent is made? Grignard reagent is made in magnesium in dry ether. Grignard reagent is made in magnesium in dry ether. So when you put magnesium in dry ether in alkyl halides, you will get Grignard reagent. है ना? Let's say I have CH3Cl. Example I have taken CH3Cl with magnesium in dry ether. You will get CH3MgCl. CH3MgCl. है ना? यहाँ पर RMgX. है ना? इसी को कहते हैं हम RMgX. है ना? R is CH3, Mg and X is chlorine. Similarly, for aryl also you can make from benzene, chlorobenzene, you put magnesium in dry ether, you will get Grignard reagent of aryl. Aryl Grignard reagent. इसको हम कहते हैं ARMgX. है ना? ARMgX. AR, Mg and X. X can be chlorine, bromine, iodine. है ना? Fluorine we never make. है ना? Difficult to break fluorine bond. Last is reaction of Grignard reagent. If you have Grignard reagent, if I am making Grignard reagent, you can do SN2 with chlorobenzene only. SN reaction हो सकता है. You can remove chlorine from here. This chlorine is a leaving group. You remove chlorine from here and you will get CH3 bond. यहाँ पर देखें, let's say I have CH3Cl Mg and CH3Cl. These two I have, है ना? So if I have two molecules of CH3Cl, same with magnesium in dry ether, I will get what? Ethane. I will get ethane similar to Woods. This reaction is similar to Woods reaction. Similar to Woods reaction. In place of sodium, I have used magnesium. तो ये कैसे? The mechanism of this reaction, how it will be? First, it will make Grignard. Then this Grignard will attack on CH3Cl and chlorine will be removed by SN2. And by SN reaction, this Grignard CH3 minus will attack on CH3 and chlorine will be removed. याद रखें, this is important point. Last point, if I have Grignard and I have a solvent which is having an active solvent which has any solvent which has active hydrogen, any solvent which has active hydrogen. If I have any solvent with active hydrogen like H2O, methanol, ethanol, acetic acid, ammonia, these all solvents. So I will get what? Alkanes. है ना? Alkanes मिलेगा. Let's say first example only we did. First example, if I have chlorobenzene and I put magnesium in dry ether, so I will get magnesium chloride, magnesium Cl, Grignard. I will get here the Grignard reagent. And if I have chlorobenzene, if I put magnesium in dry ether, I will get Grignard. And now this Grignard, if I put in this Grignard water, and जैसे ही Grignard के अंदर water डाल दिया, it is a highly exothermic reaction. It will give me benzene back. Benzene मिल गया मेरे को. Let's say one more example I take. Let's say I have this CH2Cl and I put in this reaction Mg in dry ether. Done. So what will happen if I put Mg in dry ether? I will get CH2 and magnesium will come in between. Magnesium Br. This is our Grignard reagent. If in this Grignard reagent I put water or I put CH3OH, alcohols, ethyl alcohol, methyl alcohol, ammonia, anything you put having active hydrogen. So what will happen? ये तोड़ देगा. This bond will be broken and hydrogen will be given by this. So CH3, CH3. You will get ethane. CH3, CH2, CH3, sorry. You will get propane. आपको यहाँ प्रोपेन मिलेगा. So understand better. Just understand the mechanism how it is going. Once Grignard is made, Grignard can go do SN reaction. It can attack on alkyl halides again. Or Grignard, if Grignard got active hydrogen from anywhere, from active hydrogen, from solvent, from substrate, from anywhere, if it is getting, so it will give you acid base reaction. It will give you acid base reaction, and you will get alkenes. Done. So this was all about chemical reactions of haloalkanes. Now next part is chemical reaction of halo. So this was chemical reactions of haloalkanes. Next part, last part of our chapter is chemical reactions of haloarenes. Chemical reaction of haloarenes. These two are agendas of today's class. So see. So first chemical reaction which you have learned of haloarenes is electrophilic aromatic substitution, EAS. है ना, आपने याद किया. अगर I have a chlorobenzene, in earlier class we did, if I have chlorobenzene, if I want to do CH3Cl and anhydrous AlCl3, if I want to do CH3COCl in anhydrous Cl3, these two, देखें, ये आपने याद किया ना. See, if I want to do chlorine in FeCl3 or AlCl3, or if I want to do bromination in FeBr2, these two. If I want to do concentrated HNO3 plus concentrated H2SO4, these all were part of ES. I will teach you ES in one lecture. Beta. Electrophilic aromatic substitution. Electrophilic aromatic substitution. याद रखना, क्लोरीनेशन, ब्रोमिनेशन, नाइट्रेशन, सल्फोनेशन, है ना, these all things I will teach. Second part of reactions are, today we will study beta. Second part of reactions are SN, SNAR. इसको हम SNAR कहते हैं, also known as न्यूक्लियोफिलिक substitution aromatic. एरोमेटिक न्यूक्लियोफिलिक सब्स्टिट्यूशन कहते हैं इसको, है ना। सी आई एम राइटिंग ऑपोजिट, आपको ऐसे पढ़ना है, एरोमेटिक न्यूक्लियोफिलिक सब्स्टिट्यूशन, एरोमेटिक न्यूक्लियोफिलिक सब्स्टिट्यूशन, SNAR, है ना। इसको SN स्मॉल सबस्क्रिप्ट में एंड ऐसे लिख दो, SNAR. So what will happen in SNAR? See, so let's say I have a chlorobenzene, and if I want to make this chlorobenzene to here, if I want phenol OH, so what I will do, देखें, so if I want this chlorine to be made as OH, है ना, अगर मेरे को ये चाहिए, so first what you have to do, you have to put NaOH in the reaction at 320 Kelvin and 300 atm. 623 Kelvin, very high temperature से ज्यादा है ना। Literally 623 minus 273 will be how much? 450, 350, 350, है ना। Literally 350 degree Celsius, very high, heavy temperature, heavy pressure. 300 atm pressure is heavy pressure. So if I put first NaOH, this much temperature, this much pressure. Second, I put H2O, H positive. If I put acid, HCl in water, and if I put HCl in water, so I will get this OH as our product, and this reaction is known as Dawes process, and this process is known as Dawes process. इसको हम लोग क्या कहते हैं? Dawes process. देखिए मैकेनिज्म सी, Dawes process का मैकेनिज्म देखते हैं। Is that the mechanism देखें, let's say I have here chlorine. So if I put here chlorine, और हमें हमारे पास OH minus is given, NaOH will give you OH minus. This is slow. So this OH minus will go and attack on the sp2 carbon. See, अगर ये यहाँ पर अटैक हुआ, so this double bond will be shifted on this carbon. देखें, now chlorine OH minus made bond with carbon, rest all same, double bond shifted on this carbon. If double bond shifted on some atom, you will get here negative. You will get here what? Negative. Now this negative can go further for resonance. देखें, now this negative will go further. यहाँ आया, this double bond will shift it to carbon atom. यहाँ negative आया, OH came here, Cl here, double bond here. This. Now this negative will jump on this single atom and chlorine will be removed. From here. See beta, between OH and chlorine is better leaving group than OH. है ना? So from here you will get what? You will get chlorine is removed, double bonds are made again. So benzene what will do, benzene will try to regain back its aromaticity. ये अगर OH ने यहाँ अटैक किया, aromaticity is lost. Aromaticity is lost because you have here sp3 carbon and it can't move. So once this, again this Cl minus will go through, this negative will go through whole of the benzene and will remove the Cl minus as leaving group. So Cl minus is removed. So OH ने Cl को निकाल दिया by Dawes process, है ना. See beta, this is very difficult. This is very difficult because OH minus is attacking on alkene. Alkene itself is nucleophilic and OH minus is attacking on alkene. Electron का repulsion होगा. It's very difficult to do. Therefore, they have given high temperature. Therefore, in Dawes process, high temperature and high pressure is given. अगर इस रिएक्शन को हमें कराना है, you are given high temperature and high pressure. See, you are given high temperature and high pressure. देखिए, so this reaction happens at high temperature and high pressure. But if someone wants to decrease the temperature and pressure to low, so what can I do? What can I do? देखें, let's say कि अगर if I add some electron withdrawing groups, है ना, some minus m groups at ortho and para position, है ना. So two positions are there where negative is coming, one at ortho, see, and one at para. So if I add any minus m group, at ortho or para position, so minus m group will, what they will do, they will attract the negative of the benzene ring, है ना, वो खींच लेंगे, they will pull the negative, है ना. If someone is pulling the negative from ortho and para, so OH negative directly can attack here, है ना. So it will ease the reaction, it will help to go forward the reaction. Let's say यहाँ पर, let's say I have same reaction I am taking. Let's say I have here chlorine here. Let's say I have NO2, which is acting as minus N group. Same reaction I am doing, NaOH. See beta, in this reaction I can decrease my temperature to 200 degrees Celsius and 10 atm moles. Above it was 300 atm, very high pressure. Now if I added one NO2 at ortho position, so this what it will do, it will make OH here and NO2 is made here. So NO2, what NO2 will do, NO2 or minus M groups at ortho or para will help in Dawes process. In this process, this NO2 at ortho and para will help in making our product. So our product will be made more. And conditions are to be lower. And we don't need heavy temperatures and heavy pressure because all these are not cost effective. These are for maintaining high temperature and high pressure. You need heavy cost, you need heavy industrialization things. उसमें चीजें हमें चाहिए बहुत सारी, है ना. So we always prefer the reaction which is at room temperature, है ना. So if in this reaction, let's say I add here 3 NO2, अगर मैंने तीनों NO2 जोड़ दिए at all the ortho and para, so what I can do this reaction at 80 degrees Celsius. 80 degrees Celsius means little bit of heating. If I do little bit of heating of this, थोड़ा सा हीट किया, OH माइनस डायरेक्टली कैन गो एंड अटैक ऑन दिस कार्बन एंड रिमूव द Cl माइनस. See, OH will come here, NO2, NO2. देखें, सी बेटा OH सी NaOH what it will do, NaOH क्या करेगा यहाँ पर NaOH क्या करेगा, इन द फाइनल प्रोडक्ट हियर H पॉजिटिव इट विल टेक. सो दिस वाज बेसिक मीडियम, है ना, दिस वाज बेसिक मीडियम. सो आई हैव चेंज फ्रॉम बेसिक मीडियम टू एसिडिक मीडियम टू गिव OH its H बैक, है ना. इफ दिस वाज नॉट देयर, H पॉजिटिव H2O नहीं है, यहाँ पर नेगेटिव आएगा, फिनॉक्साइड बनेगा फिनाइल के ऊपर नेगेटिव, because NaOH extra NaOH will take all the H positive, acid base reaction it will do, है ना. See, in this reaction if I don't put any H positive and H2O, so what will happen, our product will be O negative only, and we won't get phenol, OH we won't get. So if I want here OH should come, I should change the medium from basic to acidic. So I put here what, HCl or H2SO4, little amount of H2SO4 or little amount of H2O to change the basic, the extra NaOH which was there. I will try to react with them. Extra NaOH जो बचा, leftover NaOH, I will try to react with the HCl, and the rest HCl which is there, it will go and make the OH, है ना. Someone is asking this question. So write these three, very important these are. लास्ट वन टुडे, लास्ट देखेंगे, केमिकल रिएक्शंस का लास्ट देखेंगे टुडे. केमिकल रिएक्शंस का थर्ड टाइप, लास्ट टाइप टुडे, is known as, let's say I have this chlorobenzene and I put in this chlorobenzene sodium in liquid ammonia. देख, सोडियम इन लिक्विड अमोनिया, सोडियम इन लिक्विड अमोनिया नहीं, NaNH2 इन लिक्विड अमोनिया, NaNH2, NaNH2 इन लिक्विड अमोनिया. और सोडियम सोडामाइड भी कहते हैं इसको हम लोग, सोडियम इन लिक्विड अमोनिया भी कहते हैं, सोडामाइड भी कहते हैं. और so what will happen, in place of chlorine you will get here NH2. So here you will get two products, this one, if this carbon is star carbon, this one is the star carbon, here also you will get NH2. Like, this is known as direct product, direct substitution product. And this is known as Sine product. Sine product. The mechanism of this is benzyne mechanism. And this is beyond your little syllabus, beyond syllabus. So you don't have to do, you just write. If you want to convert from chlorine to NH2, aniline, chlorobenzene to aniline, if you want to convert, you can do NaNH2 in liquid ammonia. You can put NaNH2 in liquid ammonia, you will convert chlorine to ammonia. Similar way, if you have here bromine, and if I want to convert bromine, I can put here Na, sodium in liquid ammonia. If I put sodium in liquid ammonia here, you will get here NH2. Two products, one this one and one this one. These two are totally different. These two are totally different. One is attached here and other is attached here. है ना? Both products are totally different. See, I am marking this with color coding. This carbon, and this carbon is this carbon. These two are totally different, beta. कार्बन अलग है, कार्बन अलग है, प्रोडक्ट सेम। लेट्स से अगर सेम ही हुआ तो प्रोडक्ट सेम है, अगर सब्स्टिट्यूशन हो गया है यहाँ पर, एनी सब्स्टिट्यूशन इज मेड, देन इट विल बी डिफरेंट प्रोडक्ट्स। So write this, beta. So these three types you should know. For these three types you should know for chemical reactions of haloarenes. Haloarenes chemical reactions you should know. First type is chemical reactions में EAS, electrophilic aromatic substitution. You will on the benzene ring, electrophile will attack. Electrophile and benzene will react together. है ना? Electrophilic aromatic substitution we have done. Chlorine का chlorination, on benzene we did chlorination, bromination, iodination, है ना? These all things. Second mechanism was, today only we have learned, this was SNAR, which was Dawes process, है ना? SNAR Dawes process, इसको हम लोग एक और नेम कहते हैं, इसको कहते हैं एडिशन एंड एलिमिनेशन प्रोसेस। मतलब क्या हुआ, इसका मतलब ये हुआ, once OH minus is added on benzene ring, now Cl minus will go, है ना? So one is added, other is gone. So this is known as addition and elimination process, है ना? एक निकला दूसरा चला गया, है ना? So this SNAR is also known as addition elimination. SNAR को हम लोग और भी क्या कहते हैं? Addition and elimination. So these two things you have to remember. Third one we have studied today, this mechanism, which was benzene mechanism. Beyond your syllabus, but you should know benzene formula is this one. You have 3 bond between this in benzene only. This is an intermediate, not stable at all. लिख लें, just लिख लें. This is chemical reactions of haloalkanes. Chemical reactions of haloalkanes. Chemical reactions of haloalkanes we have studied on today. First was nucleophilic substitution, other was elimination, and today we studied about reaction with metals. Reaction with metals also we studied. First was Wood's reaction. Similar way, Franklin reaction. Next we studied about what? बताएं. Wood's reaction, Franklin reaction, Wood's Fittig, simple Fittig. If you have alkyl, simple Fittig. And last was Grignard reagent, Grignard reagent. Reactions of Grignard reagent. How Grignard reagent is prepared, and how are the reactions of Grignard reagent. This only we have done. Done. Better know benzene mechanism. Yes, beta, I will explain benzene mechanism. Don't worry. Benzene mechanism is there in your JEE Advanced. Thoda part is there in your amines chapter. In that chapter, I will explain. चले, with this we will end our today's lecture.